Good, you can start. Section 9.5. So this is solve application of quadratic equations. Solve applications of quadratic equations. Okay, we have seen some of the applications of quadratic equations, but we were using like one method. That method was the factoring method, if you still remember. So, but now we have like the other methods that we can use. So the first one which we did was a factoring method. Number two, we came to square roots property. And then we came to completing squares. And then the last one which we did was what? Quadratic formula. Quadratic formula. So these are the methods that you can use to solve the application of quadratic equations. So you can choose any method to use when it comes to the application. So either you can use the factoring method, you can use the square root property, you can use the completing squares, or you can use the quadratic formula. Is it clear?
Yeah. Two of them.
Why is it looking clear when I? I think it's funny. Yeah?
Yeah. That's pretty good. They're gonna load that. That's pretty good.
It's good, huh?
Yeah.
So when it comes to the quadratic formula mostly is the more accurate. It's more accurate and you can use it anywhere. So you can use the quadratic formula in anything, any of the quadratic equations. Okay. So what did you say about when you are given an application question? So when you're given an application question, there's steps which you need to do. So one of them is you must do, you must read, right? So you make sure you read the question, read it properly. Number two, identify, you can identify what you're looking for. What you are looking for. So you make sure you identify what you are looking for. Then number three, you can name what we are looking for. So you name it, name what you're looking for. So read, identify what you're looking for, name it. Then number four, translate. You can translate into the equation. Translate into the equation. After translating now, that's when you now solve. So when you solve, after solving it, then you now come and do what? Number six, you check. You check if everything that you're solving is making some sense. Okay. So those are the steps that you can use to solve an application, any application problem. So you read, identify what you're looking for, then translate into the equation, solve, and check. Right. So example number one. So we can go directly to the examples. So we can do example number one. Example number one. The product of two consecutive even integers is 624. Find the integers. You still remember the question, this question, right? So the product of two consecutive even integers is 624. Find the integers. So how should we solve this? So solution. So we can say the first integer. So the first is, let's say, what? X, right? So we can take the first integer as X. It says even. It says even. The product of two consecutive even. So if you want to get the next even integer, then what do you do to the first one? You add 2, right? So you add 2. So the second one is equals to x plus 2. X plus 2. Now the product is 624 of the two consecutive. So it will be x plus 2 equals to what? 624. 600. So therefore, this is like x squared plus 2x equals to what? 624. So it forms a quadratic equation, and the quadratic equation is x squared plus 2x minus 624 equals to 0. So that is a quadratic equation. Now you come and use the formula, the methods that we have seen. And the easiest method to apply here is what? Quadratic formula, right? If you cannot find the factors, then you can do what? Because getting the factors, the product is 624. What are the factors? What are the two numbers? Okay, so we can use the quadratic formula. So we can say A equals to what? 1. B equals to what? 2. C equals to minus 624. So we know the formula is x equals to minus b plus or minus the square root of b squared minus 4ac all over what? All over 2a. So our x equals to b is now minus 2 plus or minus the square root of 4, which is b squared. And this is minus, then it will be plus 4 by 1 by 624. All over 4. All over 4. Oh, sorry, all over 2. All over 2. So 4 plus, so 4 multiplied by 624. What do you get?
2496.
Plus 4 is what?
2500.
2500. What is the square root of 2500? What is the square root of 2500? 650. So we get x equals to minus 2 plus or minus 50 equals over what? All over 2. So then our x is equals to minus 2 minus 1 plus or minus 25, right? Right? Because you factor out 2 here. So when you factor out 2, then it will be 1 and then 25 there, all over 2. That 2 and the other 2 will cancel, right? So you get minus 1 plus or minus 25. Now, what is x? So we have gotten x equals to minus 1 plus or minus 25. So that means x equals to what? So minus 25 minus 20. Minus 1 minus 2, minus 26, right? And then the other one is 27. Minus 26. Huh? 27, no?
No, 24.
24. So we have xs minus and then xs plus. And we are talking about two consecutive even numbers. So there are the ones which are at the minus, and then there are the ones which are at the plus. So the consecutive, the next one here will be what? What do you do to this? X, you add 2, right?
Okay.
So it will be minus 22, 26 minus, plus 2 is what? 24, minus 24. So we have minus 24 and minus 26. And then the next one is 24 and what? 26. The next one is 24 and 26. So because there are two consecutive even numbers, the product of two consecutive even numbers.
You could do that from factoring though, right?
What?
If you were to use the factoring method.
Yeah, you can still do it. You can still say the product is 624. The sum is what? 2. So two numbers are 26 and 24. Yeah. So if you're not so sure about it, then you can use the what? Quadratic formula.
Yeah.
Yeah. So the easiest way to solve quadratic equation is using the quadratic formula. All right. Okay, I have another question here. I think we did some of this. I don't know whether you can see it. This thing, I don't know what's happening to it. Are you seeing it?
Yeah, it's just blurry.
Okay, it's a little bit clear.
Yeah, that's good.
So two painters can paint a room in 2 hours if they work together. The inexperienced painter takes 3 hours more than the experienced painter to finish the job. How long does it take for each painter to paint the room individually? How long will it take for them to paint the room individually? So how are we solving this? So we were saying we take how long it will take one person to do it in 1 hour, right? So we read the question, what are they asking for? So we read. So we have two painters here. So if they work together, they will do it in what? 2 hours. So if they work together, so together equals to 2 hours. Now in 1 hour, if they work together, then it is what? 1 over 2. 1 over 2. Now, the inexperienced painter takes 3 hours more than the experienced. So the inexperienced, so let's say we can take E, like the way I have done, as experience. And then the other one as inexperience, okay? So for the experience, E takes 1 over E for what? Of the time. And then the other one, who is inexperienced, takes 3 hours more than the experience. Okay. So the inexperienced will take E plus what? 3. Okay. E plus 3. So in 1 hour, this guy will take 1 over E plus 3. Okay. So we can read it again. Two painters paint a room in 2 hours. If they work together, okay? So together takes 2 hours. So in 1 hour, if they work together, it will take 1 over 2. The inexperienced painter takes 3 hours more, 3 hours more than the experienced to finish the job. How long does it take for each painter to paint the room individually? So we have the inexperienced here, then we have the experience there, and then we have together. So therefore, we now formulate the equation. So it will now be 1 over E plus 1 over E plus what? 3 equals to 1 over 2 for the total, if they work together, is 1 over 2.
Why do you have to put it as 1?
Because for 1 hour,
1 hour?
that guy will have done the job in 1 over E of the time. In 1 hour, this guy will have done the job in 1 over E plus 3 of the what? Of the time. In 1 hour, if they work together, they will have done 1 over 2 of the job. So it's like time taken to do the job in 1 hour. How far will they have done the job? So half the time, that one is 1 over E, and that one is 1 over E plus 3. So now if you now formulate the equation, so if they work together, we add the two of them. Now, if they work together, it will be equals to what? 1/2. Now you solve. So using now the LCM, if you still remember, you can multiply by the least common factor there. So, and our least common factor there is what?
E plus 3 and 2.
So E plus 3 and what? 2. Again, you do it in the other side. E plus 3 and 2. So when this cancels, so it will cancel, so it will be 2E plus 3 plus that and that will cancel, 2E equals to 2 and 2 will cancel there. So E plus. So when you open the brackets, then you get 2E plus 6 plus 2E equals to E squared plus 3E. So 4E plus 6 equals to E squared plus 8. Take them to the other side. So E squared minus E minus 6 equals to 0. Equals to 0. Equals to 0. So the product is minus 6. The sum is minus 1. So what are the two?
Negative and 2.
So one of them is negative, right? 3 and 2. So the smallest is 2, negative, right? So it will be E squared minus 2E plus
That would be negative 3 with
3 plus 2E
well, isn't it negative?
minus
the E is
6
negative, so it has to be
equals to
based on that.
0. So one of the largest should be what? Negative.
Yes.
So that it becomes negative. So when we factor out E, so E minus 3 plus 2, E minus 3 equals to 0. So using the zero product property, and then E minus 3 equals to 0. So we have E equals to what? 3. We don't take that negative. So we take the positive. So E equals to 3. So for the experienced person, that guy will take 3 hours. Now for the inexperienced, he will take how many hours? 36 hours. Inexperienced, 6 hours. Experience, 3 hours. 3 hours. All right. Okay, we have another example here. So Roy Kayal on the river, and then after a total of 6 hours. The trip was 4 miles each way. The current was difficult. If Roy Kayal at a speed of 5 miles per hour, what was the speed of the current down to the nearest 10? So how do we solve this? How do we solve this? How do you solve it? So we read the question. So after reading it, then we know. So this guy, so he went down the river, right? And then back with a total of 6 hours, right? So to and from 6 hours. The trip was 4 miles each. Okay. So total time equals to 6 hours. Distance going is 4 hours. Distance is 4 hours. Okay. Then, and the current was difficult. So the current was difficult. So that means when he was going, it might have been easy. When he was coming back, it might have been difficult, right? So either way, so it can be when he was going, the current was difficult. When he was coming back, the current might have been difficult. So if Roy kayaked at a speed of 5 miles per hour, what was the speed of the current? Or I guess E could have been the same, right? Could have been like there was current when he was going, and then there was also current when he was coming. Okay. So let's say we can say R, like what I've done there. R is the speed of the current. So speed of current. Speed of current. Now we have his speed was what? 5 miles per hour. Okay. So if let's say it was going down, so if it was going down, right? And there was current, that means what happens? The speed does what? Slows or increases. If there was current, it was going down with the current. Then the speed does what? Increases.
Yeah.
But if it was coming back and there was current pushing it back, then the speed reduces. So therefore, there is a speed going down, which you add, and there is a speed coming back, which you do what? Minus. So the speed going down is, let's say, r plus 5 down. And then the speed coming back is 5 r minus 5, which is what? Back. Now we have the total time, and we know that time equals to distance over what? Over speed. Distance over the speed. So we have the distance going, which is what? 4. All over r plus 5, and then plus what? Coming back 4 all over r minus 5 equals to total time, which is what? 6. Which is 6. Total time, which is 6. So now you formulate the quadratic equation. So that is the equation. Now you multiply by the what? The LCM, which is r plus 5, r minus 5, r plus 5, r minus 5. So we get 4 r minus 5 plus 4 r plus 5 equals to 6. This one is a product of 2 squares. So r squared minus 25. So when you open these brackets, 4r minus 20 plus 4r plus 20 equals to 6r squared minus 25 by 6 is what? 25, 6, 0 carry. 150. So 150. Now, that 20 and that one will go. So we get 8r equal to 6r square minus 150. So 6r square minus 8r minus 150 equals to 0. Equals to 0. So what do you get? I think you're doing it wrong. Here we add, so we say his speed plus the current. His speed minus the current. Okay? So we add and minus. The current is not more than his speed. Okay? So it should not be more. So here it should be add 5 plus r and then 5 minus r. So 5 plus r and then 5 minus r. So 5 plus minus r. So it should be 4 all over 5 minus plus r plus 4 all over 5 minus r equals to 6. Equals to 6. So you multiply by 5 plus r, 5 minus r, 5 plus r, 5 minus r. Okay. So when you cancel, you get 4, 5 minus r plus 4, 5 plus r equals to 6. 25 minus 1 minus r squared. So 20 minus 5r plus 20 plus 5r equals to 150 minus 6r squared. So this 25r and 5r will go. So you get 40 equals to 150 minus 6r squared. 6r squared. So you can take 6r squared to the other side, and then you take 40 to the other side. So you get 6r squared equals to what? 110, right? So r squared equals 110 all over 6. 110 all over 6. So an r now equals to plus or minus the square root of 110 all over 6. So we take the positive one, right? So our r equals to the square root of 110 all over 6. The square root of 110 all over 6. So the question was, what was the speed of the what? The current. The speed of the current is 110 all over 6. The square root. That's okay?
Mm-hmm.
Yep. Okay, yeah, one more. Now, you can also be given an area of a triangle. So you can be given a triangle, let's say of that. So this is height, then you have the base. So you must remember the formula of getting the area of a triangle. Area equals to what? Half base minus what? Minus height. Okay. Now the question can be, like this. So this is in your book. You can check your textbook. So the question can be like that. An architect is designing the entryway of a restaurant. She wants to put a triangular window above the doorway. Due to energy restriction, the window can only have the area of. So look at this. He's trying to put the what? Triangular window. Due to energy restriction, the window can only have area equals to what? 120 square feet. And the architect wants the base to be 4 feet more than twice the what? The height. The base, this base, so we can draw another one there. So the base wants it to be what? To be 4 feet more than twice the height. So let's say the height there. So the base, he wants the base to be twice the height plus what? 4 feet. Twice plus 4 feet. So what is the what? So the question is, find the base and the height of the window. So here, he use this formula. You have the area, which is 120. You have the base, then you have the height. So now we can say half times the base, which is 2h plus what? 4 times the height equals to what? Equals to 1 and 2. So we can multiply everywhere by 2. So you get 2h plus 4h equals to 240. Okay. So you open the brackets, you get 2h squared plus 4h equals 240. You can divide everywhere by 2, you get h squared plus 2h equals to 120. So you form a quadratic equation. Form a quadratic equation. Now you can use any formula to solve. So you can use any formula to solve. So the product is 120. And the sum is 2. What are the two numbers? 12 and 10. So if you take 12 and negative 10. So we have h squared plus 12h minus 10h minus 120 equals to 0. So h plus 12 minus 10 h plus 12 equals to 0. So h minus 10 h plus 12 equals to 0. So h will be what? So h will be 10. Or h will be 10. Now you take it back. So our height is 10. Now our base will be what? 21. 24. So our base equals to 2. Our base equals to 24. All right. So that one is section 9.58 of the application. So when we meet next week, we will look at section 9.5B on the same application. Some of you have not done some of the quizzes. So make sure you do all the quizzes from section 2.5 to the last one. Okay? Even if you've not done the others, you can still do them and you can still get 70%.
You know, even the quizzes.
I mean, the homework.
Oh, yeah.
Yeah. So make sure you do all of them, because if you miss some of them, then you're limiting your chances of getting some grade. So make sure you do all the homeworks. Did you stop doing homeworks?
No, I just missed last night.
Oh,
I've been doing, I know I have, there's a couple throughout the semester that I think there was.
yeah, I think I
three
saw
or
like 2
four
or
others, yeah.
3 which were not done.
Well, it was weird. There was like the schedule switched on like halfway through, like it was to where I knew the nights that we do it, so I do it those nights, and then I got behind us. It was due the night before. So I missed
Yeah,
3 or
okay,
4.
so make sure you do them. So if you do them, then you are fine.
Yeah, no, I have, I've done all of it. I'll get those done.
All right, I will see you guys on Monday.
Sounds good. Have a good weekend. Yeah, you too.
Okay, see you.